So let's get started. So I guess some of you may notice I already changed the extended deadline for the project for 10 days more. So that would be the first thing. Second would be some of you curiously keep asking me the scope of the exam. So I decided that after changing, today will be the material that we cover up to the exam. So we still basically what we will do is up to ANOVA, one-way ANOVA. Okay. Two-way ANOVA regression will not be covered in the exam, but we start to talk about that because I think they're important. But mainly we're just basically doing the Excel regression, try to tell you how to interpret those. Okay. So it's up to one-way ANOVA. And for the two sample hypothesis test, I just asked you to know how to work in Excel, right? So basically, for the theory part, mainly up to the one sample hypothesis testing, and the two sample thing, and the ANOVA, I expect you to interpret the Excel output. Okay? So, and also how to do the Excel, and that's it. And for the two-way ANOVA and the regression, we will continue to talk because I think they're important topics. But because we're not really touching the inside, but rather application, so probably you left it for your project instead. Okay, that's how I think that will fit our current situation. Okay. So again, I mean, we will talk about, we will review the exam paper at the very last class. So next Thursday, so basically will be that. Anything we are not enough, then we'll cover in the makeup. Makeup will cover out, and also things we supposed to cover, we didn't have time to cover, but okay. So let us continue with analysis of variance. Okay. Just to recall why we do that is a extension of t-test, right? Remember the t-test, a special version of two sample t-test is I have two sample and they have equal variance. I want to see if they're the same mean or not. Okay. And ANOVA is extend this model to more than one group. Okay. So that's idea. And later you will see how we do it. Is what we call a F-test. Okay. Remind yourself, F-test is what? F-test is I have two normal. They have different mean potentially. I want to see if the variance are same or not. Okay. So later you will see we will use this concept to apply to see why analysis variance works. Okay. So just to recall, the data we have is you have a set of data, right? X1, X2 up to Xn. Say suppose this is the GPA, right? The grouping can be the college, right? Or in business application, X can be, say, they willing to how much they spend, and group 1, group 2, and group N can be which store they spend, right? Okay, so that's me. Okay. Or G can be product, right? Then you can decide which product is going to be a better hit or not. Okay. So this is the notation we use is because this is not very convenient, right? So it's a group of data in the sense that you group the first group data is from group 1, so on and so forth, right? But technically, it just means this one, right? It means that you collect them in columns, right? And this is observation for group 1 and so on and so forth. Okay, so this is the main data we're looking at, and you expect when you execute Excel, this is the format that we're using. Okay, so this is the ANOVA, and do remind yourself ANOVA. We continue to assume normal. Okay, same as we do the t-test. Okay, we have two bells. Okay, so here is what we have, and the key point is we have to assume equal variance. So it's a special case for extend, right? Two sample t-tests, you can have different variance or same variance, but we have to make the same variance for ANOVA to work. Okay. So if you assume xi is a bell, you can rewrite it as a part xij every observation, follow the mean mu I, where mean the mu I is not a the stochastic, it's not probabilistic, so it's a constant, okay, plus a bell, okay, because this bell is just shifting and the constant shift, so this is a this additive formula is like this. Okay? And now we are going to define several things here. Okay, first is what we call the grand mean. Okay, it's average of all the groups. Okay, and what we call treatment effect is how each mean of each group is different from mu, right? This alpha will be 0, okay, if there's no difference between groups. Okay, so that is the alpha I is the thing that we want to see, right? You want to see is mean of each group different from overall mean, right? Because the idea is coming from the treatment idea is the idea that we're doing medical treatment, right? The end treatment, and we want to see if the treatment are going to be positive or negative or different from 0, right? So that's the idea. And the next thing you want to ask is if there's a model, how can we estimate mu1 up to mu c and also mu, right? That is something I guess it's not difficult to guess, right? If I want to estimate the big mu overall mean, I just use x bar, right? Add all observation up divided by n, right? That's what it said, right? You just add up everything, right? What it means is you go from group 1 up to C, right? And adding up all observation over how many of them, right? And this is sample mean of group I will be just adding, okay, group I's all observation there over how many of those. So that is very simple, right? Just look at this diagram, right? Again, group mean, so grand mean will be just adding everything up, divided by total of them, right? That if you add them up, divided by total of them, right? That would give you x bar, right? If you just add up this column and divide the total number of them with x bar 2, right? So on and so forth, right? So that would be it will be x bar 1, right? And why do we estimate this? This is good estimate for mu, and this good estimate for mu1, and this is mu2, right? And we want to see, right, whether the mu1 or mu2 equal to mu, right? So that means that I want to look at data. I want to see if mu1, sorry, x bar 1, x bar 2 is very different from x bar, right? And if they're totally similar, then we don't do, right? If they're different enough, then we want to do hypothesis testing. Right? So that would be the goal again, right? So because we want to see whether group difference group mean is different, right? So that is the idea. Okay. And you want to see graphically that what it means by mu, epsilon, and alpha. Okay. I'm sorry for the notation. I put it there because usually this is how people write when they write probability model. I want to prepare you to if you study further. Okay, but if you that's not necessary for understanding. Okay, but I just want to put it there. You will see if x, the red one, right, is a bell curve, right, center mu1, right, you can actually, okay, put the mu because it's constant, you can always move the center. This epsilon, right? And if they're same shape, right? So everything you can move it back to epsilon 1, but with this alpha, right? So as long as I know the alphas, epsilon, then actually same as I know x. Right? So the same thing. And so as I said, if I want to estimate mu and mu I use the x bar and x bar I. So that is something, probably it's not something complicated to know. And this is how you actually do the calculation. Okay, don't worry. You plug in Excel later, so they give you everything for you. So you don't really worry. Actually, the calculation, but I just put it there in case you want to know what are those. Okay. And I think it's easy, right? Just add up everything, right? This guy, right? You add this divided by 4 is this guy, so on and so forth. I guess this slide I don't need to review again. Okay. Now, as we said, we want to know each group mean are the same, right? Or what we call is the treatment effect are 0, right? So that means I want to see the group difference, are they meaningful, right? You can do medical tests or the customer of different group are different, right? And later we argue it's actually an F test. Okay, the logic is not difficult, so you will see very quickly. So the idea is very simple. Now, so to do it, we have to do some math. Okay, and you probably don't need to worry about the formula, but you need to know what are they. Okay, that's important. What are they? The first one is called sum of square total. So that's by SST, sum of square total, SST, right? Usually you call sum of square total. So that's why SST. What does that mean? It means that you look at each observation minus the grand mean, right? And take a square, right? So basically just you disregard the grouping, right? You calculate the group mean, which is x grand mean, which is x bar, right? Every observation minus the mean and square, right? While you calculate that, this is usually you calculate variance, right? The numerator, you calculate variance, this is the numerator, right? The sum of squares. Okay, although we didn't talk about this terminology, but this is what you would do, right? When you calculate variance, right? So this is the part that numerator for the variance. Later you see, but this is what we call SST, right? It just, you don't care about the grouping. If you care about variance of the data, right? This is what you calculate the numerator. Is that clear? Right? This is nothing particularly deep here. Okay. The second one, okay. The second one is called the sum of square between groups, SSG. Okay. And do note that different textbooks have different very complicated way to do it. They sometimes it's called, they swap the W and G. I follow the textbook. No, I follow the Excel. So this is for Excel. Okay. SG is what? SG is like, it's very simple. Because I want to calculate variation between groups. Okay. So what I do is look at the equation. I don't use Xij. I use Xi bar. Right? Notice what I'm doing is I replace each observation by its group average. Okay. So what am I doing here? What I'm doing here is like, look, go back to this slide. Okay. I have all the data here, right? What I'm doing is all this number will be replaced by its group mean. Okay. Calculate the mean, replace everything by itself. Do every column, right? And then I calculate variance. Why I'm doing that? If I do that, it means that there's no variation inside the group, right? So what you left is actually variation between groups. right? Because within the same group, same number. Is that clear? So that's why it's sum of square between, right? So that's why, right? So that's why the SSG, right? Sum of square between groups. Only the group Lession. So that's what it means. Okay. So we place all the observation by its group mean and calculate for variance with the numerator here only. Okay, numerator only. Okay, we'll divide something, then we'll give you variance. But this question. Okay. The next one is we care about variance inside the group. Okay, so that means that's why within group. So that's why compare this and this one, right? You look at this. What's extra is this? There's no I here. There's I here. What does that mean? You calculate variance for each group, right? Right. The main idea is, right? You calculate variance for each separately, right? And that is the main idea. It's called SSW. Okay. And not surprisingly, overall variance is variance between group and variance within group, right? Because you separate overall variance, it's variance across a group and variance within group, right? So that's the main idea. Okay. How to prove it? I'm not going to prove it, but that's a proof to show you that this is true. Okay. You don't need to worry about the calculation. No one actually work it out. Okay. Everyone rely on calculator anyway. Okay. I never calculate by hand, right? At all. So, but you know what are they? Okay. Just to repeat what it is, right? It just, right? The variation, total variation, right? Overall, right? With across group, within group, right? Total will be across group plus within group. It's always like this. Is that clear what it is? Okay. We'll divide something to get the variance. So, but don't worry, but that is the calculation. And so basically it's like this. Okay. Now look at this particular black curve. Okay. And observation 1J belongs to group 1. Right? If you calculate variance, it's what? From this to the grand mean, right? And square, right? And divide total on that, right? That's the SST, right? The square distance, right? But if you look at how this to its own group mean, it's called SSW, right? Within group, right? And from here, each group to here, it's called SSG, right? So basically, just decompose it, the total, right? From itself to the group mean, which is SSW, right? And from its group mean to the overall, it's called SSG. Okay. Of course, it's not the proof. Okay, proof need do the math, but that is intuitively decomposed, right? So that is the variation. Okay, so that is the idea behind the proof. Now we are going to this is just to try and show you how the calculation, right? So SST just subtract every number minus 4, the grand mean, and add them up. Okay, so that's what it means, right? And SSG is just very simple. You replace this by 2. That's why I should do 2 here, because it's group mean of 1 is 2. This is 3, so this is 5 and 5, so we just replace by 5. Okay, so that's how you calculate. But don't worry, you never calculate this. Okay, I just telling you that how we do this calculation. Okay, I'm not asking you to reproduce this green thing. Okay, the green thing is just trying to tell you what it is. Okay. Of course, I expect you to know this equation. Okay, later you will see the Excel will tell you this equation, but this equation I expect you to know. Okay, and SSW, right? You just every observation you subtract from its group mean and square, right? So this is to verify this formula here. Now, as we said, we want to calculate variance, right? And under the null, right, they have the same means, right? So the first one actually is estimation of sigma square, right? This is sum of square total MST, right? This is fine, no problem, right? This is a standard way. If I don't have grouping, this is how you estimate the sigma square, right? Right, because I don't have any grouping, right? Everyone minus this over how many observations minus 1? Fair, right? The next one, okay? Turnouts is MSG over C minus 1. Okay, C is how many group of them? Okay, why this is also a measure, right? Because of the group mean is also a random variable, right? It's also a bell, right? And under the null, right? They have the same mean, right? So this guy, okay, you only have how many mean of them? You only have C mean. C, suppose group is 9, right? And minus 1, right? How many means there? Right? How many group mean there? You only have 3 groups. Suppose, like in this example, right? How many group mean you have? 3. Okay? So you calculate variance among them, 3 minus 1, right? As denominator. So that's why C minus 1. Okay? And this is the variance you estimate from within the group itself. Okay? And why you divide M minus C here? The idea is that actually you estimate C group mean, right? So that's why you have to minus C, right? If you estimate only 1, you minus 1. You estimate C of them, you minus C. Okay? That's why in the textbook, they call degree of freedom, because once you estimate one thing, you have to minus 1. The reason is actually by math. I don't want to prove it, but that is what it is. Okay? So I don't expect you to remember this formula, okay? But I expect you to know how you get from here, right? So because there's n, you only estimate only one mean, so there's n minus 1. That's the standard thing we do, right? And here, because you actually replace everything by the same, so that's only C variation, right? Because there's no variation within group, right? Only C different value, right? So C minus 1. For this one, M minus C, is because actually you only have estimate C group mean, right? So minus C, right? You estimate 1 minus 1, okay? And probably it's not a good explanation, but just remember it as a formula, right? If you choose to. Okay? So what is the key here? Okay, the key here would be to say if there's no actual difference between group, okay, we should expect this and this will be very similar, right? Otherwise, if the actual difference, this will be much larger, right? Because this what is capturing variation between group, right? If they actually locate the same place, they actually captured by the variation should be captured by sigma square, right? But if they actually further apart, right? mu1 not equal to mu2, not the same. This will be much larger, right? Because you measure between group. Look at the graph again to help you to see this idea. Okay. You see here, okay, SSW or MSW, right? It's measuring how this within here, right? Should be somewhat given by sigma, right? But you look at your data, right? MSG is measuring how these are related, right? And if they actually difference, right? So this guy will be very big, So the idea is that if they actually have very different, the group mean will be very different, right? Group mean, the variation between group should be much larger than variation within group, right? Because if they're actually no difference, actually they should be the same, right? So that's the idea. So that's why ANOVA, just this graph, just that F test is trying to see if this over this, okay, is it going to be a more? So it's a right tail test. It's a one-sided one. Okay. So as I said, we're not going to do it by hand. So we now immediately jump to Excel to tell you what to do. And I want to focus on the Excel output will be like this. So this is the thing that I want you to focus on. This is the thing. I mean, we'll do it, but I'll tell you what is this graph about first. Okay. So you have data here, as I said, group 1, group 2, group 3. Right? It's 1, 2, 3. And they will tell you what is the sum or the average variance, but not very useful here, but the most useful thing is here. Right? So you have, this is between group, right? As I had, right? SSG, SSW, SST, SS, right? So add up this guy, right? And DF is what? DF is for this C minus 1. How many group you have? 3. 3 minus 1, 2. Within group, Y is 9, is N minus C, right? N is 12, right? 12 minus 3 is 9. Okay, this is N minus 1, right? 12 minus 1 is 11. But anyway, this add up to this guy, right? So this add to this guy, this add to this guy, right? This is coming from that, and this is how to calculate this, right? Remember how to calculate this, right? Between group, right? You replace this number by the mean, right? Take this number by the mean and replace number by the mean and do the average, right? And that's how you get this one, right? And this one within group, right? You just take this minus its mean, right? And do the same for the rest, right? To get this number. This is also the same thing, right? SST, right? Does this subtract from the grand mean? Do the same. Okay. And how to get this to? This is MSG, right? So this over this thing. This over this, right? How to get this one? This over this gives you this one, right? And how to get this? Will be using the F, right? So how to get this number, right? Will be it's very simple, right? Just F inverse, sorry, F this, right? And 2.3478, right? Degree of freedom is this 2 and 9. 1 minus. Why 1 minus? Because right tail test. Okay, and that's it. And in this one, this p-value that you don't reject. Okay? And that's it. Of course, I will do Excel again, but this is the thing that I expect you to know how to operate it. You can see the past paper after this one. Okay, so you expected to know this very well. Okay, because that's important. Because in actual practice, that's what you do, right? You run the data and make judgment based on this one, right? So you need to know how to calculate all this, right? If I try to block something out, you should be able to come up with the rest. Okay, so now let us tell you how to do in Excel. But before, I mean, I'll go over the table again, but that's the main thing. Okay, do remind yourself what are we doing here. We're doing here is to try to say there's a group data. A different group have different mean, right? And this is very often we do, right? That's maybe you are thinking about different marketing practice, right? Or different day of the week, right? You want to see whether each different day will have different sales, then you may decide different programs. So it's very common that this kind of problem arise in actual practice, right? Because you want to see different group have different thing, right? So now let us do the Excel, then hopefully okay. So group 1, group 2, group 3. Okay. So the data maybe group 4, maybe much more fun, right? Group 4 here. And here ANOVA, one way ANOVA, we need not have, we can have different number of observations for each column. They'll be same. So let me do, I just randomly put something there. You don't have to follow my way to do it, but I just randomly put number there. Okay. Okay. So that is the data I have. Maybe make it not too large. Okay. So this, okay, you can see this data. I have 4 groups. Okay. Okay. This is the data I have. Now, what I want is I want to have an over there. Okay. And don't worry, it's just one click, then you're done. Okay. Just do one click. Okay. We will have a very simple thing. So how do we do that is we need to figure out what we call, I don't know whether you have, I think you should, for Mac still have that, is we call the add in. Okay, so let me go step by step. You go to file, option, add in, and have NS2 pack. Okay, and then you have to open it. Okay, and after that, the data, we have data analyst. So probably you should have also have that in the math as well, but iPad probably not. Okay, I'm not sure iPad have it or not, but that would be important. Okay. Yeah, you have that. I mean, for the Mac, you also have that. Okay. So once you have that already, you go to data analysis. Okay. And you can see actually there are many things you can do here, t-test, whatever, but we can talk about that after the break. But we focus on the thing we want to talk about today is ANOVA, which is the first one. Okay. ANOVA, single factor. Okay. Is there any problem for you? Let me know, because there's one click, then we are done. So nothing new here. But make sure everyone has there. But if you're using the iPad, then unfortunately probably not going to work. But I hope you have a laptop at home, then you can try that again. Okay. Once this is done, click OK. Okay. That's very simple. Click OK. And then you tell them input range. Is tell them what are the input you are. And the data I have is grouped by column, so that's what automatically that. And I have label in the first row, right? So that's that. That's that. Alpha, you know what we mean, right? 5%. Right? So that's standard. So you don't have to do anything. So the only thing, click label in the first row, tell them the data I have, right? Just click everything there. And N. Then you tell them last is where I'll put your stuff. Usually I put them in the same page to make things easier. Okay. Tell them I'll put here. Okay. And once I've that done, okay, okay, then it's done. Okay, but before I do that, is there any question? Okay, so that is the thing I need. Okay. So let me get it smaller. Okay. Okay, so this is the data I have, right? Tell the count, average, variance, okay? And this is SSG, right? Recall how to calculate that again, because I want to emphasize, right, how to calculate this guy, right? These guys come from the fact that you don't have to, I mean, you don't have to do a calculation, but you need to know what are these, right? This SS between group means you replace each observation by its group mean. So you basically replace this by this guy, right? 3.2, and second column by 3.6, and so on and so forth, and calculate, okay, the variance, right? The numerator for the variance, right? Minus the overall mean and square, right? And this is, you calculate the overall, right? But anyway, you will see you adding the relation between all the yellows, right? If I give you, okay, any of, I omit any of the number, you know how to calculate the others, right? That is something you know how to do, right? That's how we calculate that. Okay. And you ask why DF is 3, right? Because between group, right? This is group minus 1. You have 4 group, 4 minus 1 is 3, right? And within group, this is N minus C, right? Because within group, you estimate C group mean, right? So total number of them minus C. So how many data you have, right? Is 7 plus 5 plus 8 plus 9. How many is that? Is 29. So 29 minus 4, right? So this comes from, right? Because N is 29, C is 4, right? This guy is C minus 1, right? This is N minus C here, and this is N minus 1, right? So add up the same, right? So you should see this, add this is this guy, right? Is that clear? And you go to this number, right? This number is what? This divided by this is this guy, right? This divided by this is this guy, right? 7 points. Maybe you don't believe me. Okay, seems some people have a confidence crisis here. So, you take this divided by this. Give it some. Okay. I hope now you can believe me. Okay. So you divide the column of G by column of H, give you column of I. Is that clear? How we get all the number there. Okay. And how you get column J? Column J is 2.5 over 2.0, give you 1.20, right? Because this is MSG over MSW, right? This is MSG, this is MSW, right? This is F. And this gives you 0.3, so you don't reject, right? And some of you ask, okay, how can I get that from the 1? Is, remember, 1 minus F this, as I said, right? This number, this degree of freedom, this that, and then true. Okay, so I just, and probably this is the one that is most complicated one, right? So that would be the one that you want to do, right? And the last thing, probably one of you ask the critical value, right? Of course, this is less than the critical value, then you don't reject anyway. But some of you want to know how to calculate this guy, right? This is the value that you reject, right? So we're asking the 5% at the end, right? So that means that this number is coming from F dot inverse, right? We want 5%, so it's 0.95, right? And we have degree of freedom this and that. Okay, so that's how you get the number. Okay, so that is how I get these two. Okay, and this exactly what I get here, right? Yeah, remember the idea of F-test, right? Is compare the variance between group and within group, right? Because they're actually capturing the sigma square if they're the same mean, right? If not, then actually you would expect the between group is much larger than within group, right? Because within group is look at how the variance within the group, right? Across group, if there's no difference, then it should not be larger than within group, right? So that's the idea. I hope that's clear. And some of you asked me how to use F table. This is how used here. Okay, F table found the critical value. Okay, this critical value gives you 325. The table. So let me show you the table. If there's no problem, I show you the table in the slide. So go back to the slide here. How can I find the F table here? Okay. F table is here, right? So this is the table at 5%, right? And I want is C minus 1 is the degree of freedom is what? It's 325. Okay, then it's somewhere here 325. I want 24, but anyway, it's like 3. Okay, I don't have the 25, but 3 something is the critical value to be shown there. Okay, of course slightly smaller because 25, I want 24 in the table. Okay, so that would be how you would use the F table. Okay. Okay. So basically, this is the up to this point will be the coverage for the exam. After that, I will of course still talk about stuff, right? But I just because some of you are very anxious about things I cover too much, and then you're very busy, you don't want to study next week. But anyway, so fine. So I just cut off here, and right. So obviously this would be very important. I expect, right? I expect you know how to do that, right? Because it appeared in the last year exam, right? So you might expect something will be asked again because it's a very important thing. Okay, I expect you know how to read this table. Okay. Any question? Yes. Oh, same as 5%. Then that 5%. So if the p-value is less than 0.05, then you reject. Or if you say the F, which is column J, is it more than the column L? Right? If more than that, then you reject. Right? Because F test, right? Remember the F test is like this. The F test is maybe I might draw here, right? The F test is like this, right? F like this, right? You have 2.9 something, right? And this is 5%, right? And what you get is 1 point something, right? I forgot, but it's not in this, right? Right? So you don't reject, right? Remember the null hypothesis is they have the same mean, right? mu1 equal to mu2 equal to mu3 equal to mu4 equal to mu5, right? So basically, this is pretty much what we cover in the exam. Not saying that the ANOVA regression is not important. They're very important, but since we are basically reading the table, reading the Excel output, so actually that's, even though if I don't ask the exam, it's going to be an issue, right? But I cut off here because I think that would be most appropriate. Okay. So, any question? If no, the break in the break time, you can ask me. Let me do you reply to see. Since our exam is cutting off at this point, so if you have any question, I will try to answer the Q&A first before I continue to talk about more complicated ANOVA and regression. Okay, because because we have enough time to do that because it's running Excel, so I don't think we need a lot of time. So I will prioritize that first. Okay, because we are makeup class anyway. So if I don't have enough time, I steal some time from the hour. I hope you don't mind. But otherwise, I will just prioritize on the Q&A first. So please write down if you have question you want me to clarify. Okay. Sample variance of the group. Oh, that is what you mean. No PowerPoint. This is the Excel formula. Yeah, but this is the variance with different data. Forget about it. Variance. I mean, like in the pitch observation. And then we calculate the mean first, right? Subtract every observed mean square, add up, and then divided by n minus 1. Right? This go back to the top point. Oh, you're more than specific. What is your question? I'm not sure you what is your question. You said like we need to understand the context. I'm not going to answer any question. Said what I mean only what I asked in the exam, right, must be something I thought. Yeah. No, we just replace this by set average. Right, basically. Okay, so I guess we can check. Okay. Can you explain about when the variance the group between group? Oh, variance between group is always no less than within group. Okay, but if the groups are different, the between group will be way larger than that, right? Because they're different. Between group is more than within group, right? So that's why the F test we try to see if this is true. If this is true, they cannot be the group cannot be the same mean. Is that clear? So let me repeat once again. Okay. If you talk about where within group, right? Which is the MSW, right? It's not talking about within the group how they vary, right? Okay. And this is looking at variance between group is looking at how the groups are different, right? And if the group are actually very different from each other, this one will be very large, right? Much larger than this one, right? So that's why the F test is asking whether this is larger than this. If larger than that, then reject our claim that they're the same, right? That's I hope it's clear why this is true. But again, I mean, I'm not going to ask this kind of question, right? I'm not going to ask conceptual question, right? Basically all the calculation part, but I hope you understand what it is, right? Otherwise, what are you doing, right? So I hope you understand what's going on, but how the second question is how do I find this one? Oh, this one? This one is just this, right? Right? This is 0.0. Okay, how do you find this number there? Right? Is F inwards, right? Because it just from area to the here, right? 0.025, 49, 39. That's it. I don't know if I answer your question, right? Just Excel. And if you really want to do the F table, it will be something like this, but I don't have that in the table. But F table, looking at 5%, I don't have in this table because this table only look at 5%, but yeah. But as I said, for the two sample hypothesis, I need you to know how to do Excel, right? So you should able to do Excel, right? So is that clear? What is the decomposition in the ANOVA part? Oh, you see that here. That is how you this one. This add this one is this one. That's the decomposition, right? Because total variation is same as variation between group plus within group. That's it. That's the decomposition, right? That's the only thing. I hope I answered your question. So don't worry if you still have a question, even after the class, you can talk to the TA or ask again next class. Will the first topic? Yes, first topic definitely ask, right? Why you would think mean is not asked, right? All of the exam question calculations. Yes, all the calculation, all based on calculation, not asking you to tell me what is X and Y, Z because open book, right? I'm asking what's hypotesting, just copy what is mean, just copy. So no point. Basically just apply, right? And do we need to explain graph with text? Up to you. Just we care about your calculation. If graph help you to do thing, then it's good, right? Because sometimes you do hypotesting, then draw the graph. And the question, I think now I make the exam easier, so only 3 questions instead of 4. So 3 questions, 3 long questions. I mean, each question have 4 or 5 parts. So 3 to 4 parts. Yes, we are not asking ANOVA. So today is the up to this point that's it. Okay. I'll clarify the scope in the Blackboard announcement. I detail what is included. Okay. So up to the theory part will be mainly up to the one sample hypothesis testing. Expect you to know how to do Excel. For the two sample t-test and ANOVA. How many pages of cheat sheet can you bring? Infinity. As long as you can fit your own bed, that's fine. And do remind you can't share cheat sheet, okay? Use your own, okay? Because you are sharing cheat sheet is actually cheating, okay? Cannot share cheat sheet. Okay, bring your own. Okay. And yeah. When is final exam and where? The final exam is going to be next Friday, just an hour, YLT 5, 4:40 to 5:45, and that's it, 1 hour. Okay, and I don't make it 4:30 because people come late to the bus, so that's why I allow you more time. Okay, just an hour. Okay, no extension, just 1 hour is 1 hour. Okay, no extension. Don't ask me for extension. Just an hour is an hour. We're done. You're done. Okay. So 3 questions, 1 hour. So I don't know. I mean, it should be fine. Remember last year I had 4 questions. Now I have 3 questions. So it should be easier, right? The scope is less, right? I hope that. I will not explicitly tell you 1 tail, 2 tail, but I will tell you what the hypothesis you are doing, right? You tell me, right? If I say test the hypothesis, the sample means equal to 3, then you know it's 2 tail, right? I want to test whether it's more than 5, then you know it's 1 tail, right? So I will not explicitly do a 2 tail test. That would be too direct, right? But from English, you can infer, right? So basically, the answer is yes, but not directly tell you the answer, but just slightly little bit understanding, right? But otherwise, it would be simple. It would be something like that. So if you still have question, you can ask next class. With next class and the class after is like we cover something new and with some Q&A. So if you have a question, just let me know. As I said, the ANOVA, the regression, the assignment, the solution will be released. You get that assignment for free for full credit. The last one, okay? So that one is given for free. No need to do. Okay. I hope make you happier. So this thing I have to remind. Today is not Monday, it's Thursday. So just don't make a mistake. Yeah, SST, SWS. Yeah, that is the main thing. ANOVA, that's good. The overall is okay, the speed. Mostly can follow, but of course, so what is the food English? Jessica, is it something I should know? I don't know. I don't know. You are going to fail that. So far, I only failed 1 student, who don't submit assignment, who don't do the project, who don't do the exam. He's the one that I failed throughout my 10 years history. So if you want to try to do that, maybe you can do it if you don't take the exam, don't do the assignment, don't get the exam, don't do the project. But if you do everything, then you shouldn't get a fail, even the way we structure our assignment. But if you want to challenge that, you can try to do that. I mean, but you're here, like unlikely you do that. But if you don't do anything, then it's likely. But yeah, that is the variance, right? It's very hard, surprisingly. So I hope that you understand what's going on. But if in any case, you can ask me. Okay. Now, the remaining time I will talk about some Excel as well, and some regression, but I will talk about very quickly talk about two-way ANOVA, but I will not talk too much because since I know everyone will be hooked to the exam, so if I cover anything about exam, probably you are not that interested. I will keep it very short, very brief. Okay, so make sure that you don't feel too bad listening to that. Okay, two-way ANOVA, don't worry, it's very simple. I want to tell you how can you implement in Excel because you may do it in your project, right? Although it's not an exam, but you can run the Excel in the project. That's easy, right? So the idea is super simple. Okay, they're very simple. Just what we have the data is not just about one factor, one grouping. Okay, you can imagine that consumer can be distinguished by male or female as well age group, right? Then the question why we want to care about this is, suppose a marketing manager, you want to target a market segment to put there. Then you run an ANOVA, see if they're the same. If the same, then you want to produce a product for everyone, right? If you see a particular segment of the market and focus on, this is how we do, right? So this very natural question to ask. And the idea is that the data will be every observation will have two grouping, right? Whether it's your gender, age group, right? So that's the idea. So again, the question, this is the data you have, right? The data, the grouping, that's it, right? There's nothing new here, right? Again, okay, there's some restriction on the way we do ANOVA, okay? Here is, we assume we call equal number of replicates, which means that for each combination of age group and male or female have the same number of observation. Okay, why we do that? Because to make our formula doable. Okay, there's not a restriction on the model. It's just Excel cannot do it. Okay, if you don't use Excel, you can do it. Okay, just Excel restriction. So because we are focused on Excel, so the idea is very simple. Okay, again with the data like this crazy. Okay, look like the data look like this. Okay, A is the group of female or male, B is age group, right? So this you can nicely put it there. Okay, I'm not going to bother you with the notation. Okay, so what it's asking is like this. I'm not going to the math, whatever. Okay, the question is asking. I'm not going to it. Not even going to that. Okay, the question asking, go back to here. Okay, is data, the gender will be different, age group different, or particular age group and gender will be different. Okay, so that's why when you run the ANOVA, which I will tell you soon, the output is very similar. Okay, you have something very similar here. Okay, and you have within, okay, and there will be A, B, and AB. Okay, what I mean by that is, okay, this is within. I think you know what it is about. Same as before, right? Each data minus its group, small group mean square, right? So what is the column? Column is the data we have is whether, remember A are age group, gender, right? So this is gender difference. Okay, and this sample will be called age group. Okay, and interaction will be asking if there are difference between potentially different age group with different how can I explain? So maybe there are no difference between age group and gender. Okay, so maybe men and women are the same. Age group can be same as well, but maybe old men want to spend more in particular. Okay, it's not about age, It's not about gender, but maybe you have old men want to spend more, or a young girl want to spend more. Okay, a particular specific group have different thing. Okay, so in that case, what you do is look at the p-value. Okay, the same, whether it's less than 5%, and they make decision. Okay, let me repeat what is two-way ANOVA. Okay, two-way ANOVA is just asking, we have two things here, right? Each observation, make it easier, right? We have age group, right? The data is age group, right? Maybe gender, right? Gender here, right? Gender maybe male, female, right? And age group maybe kid, right? Young, middle age, and old, something like that, right? So I look at the column here, right? This value. The p-value will tell us whether this data tell you the man and the woman are different or not. This gives you this p-value. The sample will tell you whether age group will be different, right? Basically just doing ANOVA separately, right? Same as doing ANOVA one by one, right? And you have interaction is what? Interaction is maybe it's not about man and woman. Maybe just a particular old man spend more and particular young woman spend more, or the kid will spend less. Okay, there's something special there. Okay, then you would be captured in the interaction. Okay, and it's very difficult to talk about interaction without going into the model, but you can imagine just saying that there are things not captured by gender and age directly. It's not linear, you can say, right? Anything is non-linear, right? Because we're saying, right, all the male are better than female. We're captured by this, right? If age group difference, if this is more than this is more than this is more than that, we will capture it by the sample thing, right? If I only have this is more, this is more, this is more, and this more, right? Or somewhat where we are combination, we capture by the interaction. Okay, and you probably ask me why I do that, but that would be something you would learn it if you do it further. But it's asking whether interaction is whether age effect and gender effect are related, right? Maybe you're thinking OP, maybe the product is like doesn't change. Female don't want to pay more, right? But maybe all female want to pay more, right? So that's the idea. Okay, that I hope that makes sense. Okay, because if all the female will pay more, will be captured by the columns, right? If all the, regardless of man or woman, right? If the older actually pay more, will be captured by the sample, right? But if only all female want to pay more, will be captured by interaction. Okay, so that is the idea. So don't worry about that. If you ever have to use, to be honest, I never use it. I only use this tool, so that's why I didn't want to talk about too much about it. Okay? Because although we do ANOVA, but indeed this is an outdated tool. Everyone do regression anyway. So actually, I never do this. But if you do marketing, maybe you do it. But for me, I never do this. Okay. Actually, indeed, I think no one actually do this anymore. Everyone just do regression. So that's why ANOVA, I just want to go with real quick, because ANOVA, I want to do quickly because in the old days, this is what happened in the 100 years ago. People ANOVA, and now everyone want regression. I don't see anyone doing ANOVA. Maybe B school, medical school, they still ANOVA because the things are simple. Or the sociology, some people do ANOVA still. But most of people just do regression because regression is more general. Everything is nicer. But when you learn something simple first, right? If you learn the next class is 2021, I think it's good, right? Then you learn multiple regression. This will include ANOVA as a special case. So that's why no one actually use it, right? Because it's a special case of a much more general framework. So that's why I don't want to bother with that. Is that okay? So as I said, I don't want to talk too much detail because it's not important anyway. No one actually use it. But I still want to tell you what are they, because you know what to be done if you really want to test your data, right? Because you say you're supposed to really, so what do you do that? Why you do that, right? Suppose you reject this interaction, right? That basically tells you that some of the things is different from the others, right? Then probably you can say pick up this group and do a t-test, right? And you can see whether this particular group is more than the others. Then you can do more, right? So ANOVA in this context will be a first run analysis, tell you whether there's something you can do, right? Because you have a lot of data, right? Many categories, right? And interaction tells you maybe you want to pick up something very special, right? If you reject this interaction, right, then you don't need to worry, right? Just focus on whether or man or woman, young and old, you're done. You don't have to worry about particular group there. Okay, so that's the idea. I hope that answer question that you might have. Okay. So, and in case you ask how you do the ANOVA, will be just, this is your input. You use the application and tell them your data, how many row and alpha, then you're done. Okay? So that's same as what you do regress, same as one-way ANOVA. So there's nothing very deep to conduct your data. But as I said, I never do this. In practice, no one actually do it anyway. So I don't know what is the benefit, what is the use of that. One-way ANOVA, still we do it. Okay. And two and over, I don't actually see people doing it anyway. So that's why, whatever. Okay? I think it's no harm to skip it, because if you ever use it, you will do regression anyway. Okay? So I think that's should not make you very sad. We don't cover an exam, right? I don't think you would complain, because I don't think it's very useful anyway. So omitting from an exam, I think you don't complain, right? You don't feel bad if I don't put it in exam, right? I mean, of course, let me know if you want, I can put it back, but I don't see this. Is that okay? Any question? Any question? Now I want to tell you the last topic, okay? Although probably you don't have any much intention to listen, but I would say this is I hope I still have you, because regression is I would say, one of the most important thing if you learn statistics onward. Okay, and some of you would ask, okay, why do regression, right? What is the underlying? But if you learn machine learning, big data, or those things, artificial intelligence is more or less is a regression, but a different type of regression. Okay, and you call machine learning is like the basic one is like a kind of regression, but let's get started what it is, but don't worry. We'll focus on conceptual thing. It's not very complicated. Okay. And regression is trying to discover relationship between variable. You learn that from topic 1. We calculate covariance and correlation, right? And we want to say, probably every one of you would think that's important. Whether after your undergrad, you want to do the master, right? Asking, spend 1 or 2 more years in school, is it going to increase your income? Okay. The answer in general from economics is you always want to study up to master, Okay, at least up to master, you're still making extra. Okay, but up to like me, PhD is decreased. Okay, so you have a like is the should look like this. Okay, so if you have primary school, okay, and secondary school, okay, and bachelor and master, okay, and PhD, maybe I just draw the other one, maybe a bigger one, right? So like this, right? This primary school, this secondary school, this bachelor, this master, this PhD. Okay, what's the income? In general, look like this. So why? Permanent head damage. So your head got damaged, so that's why like this. So and they're not too much different from. There's some difference between primary and secondary school, and college is a big jump, especially you do professional or you do a degree that make a return. And master usually you also got a good return. Okay, and do that. Okay, do note that this graph does not imply you should do master. Okay, the reason is being that the choice of doing master is what we call endogenous. Why? Okay, if what this is because this is not, you see the correlation, what we emphasize is not causality. The reason is being that who is going to study master, it's likely that in the admission process, only the one who have high GPA can be admitted to master, right? So not everyone is open to everyone, right? So basically you're talking people with master already top in the bachelor, right? So it's likely that they earn more, right? So you have to be very careful about this graph, and this won't tell you anything, right? But that being said, if you're able to gain a master, then maybe you should do it, right? But doesn't mean everyone should do a master, right? That's a different thing, right? If you can get in, it's good to do it, right? But you can't, don't be so sad, right? Maybe not so bad, right? But if you get a PhD, probably not sure, right? So that is a graph, right? So I want to discover that, right? So that's a regression do. And the second thing you want to care, if you are the marketing manager, right? You decide how much to spend on the sales, sorry, advertising, and then leads to sales, right? That's a question, right? Or if you are a company, right? You want to see the drug dose and recovery time, right? Decide what is that, okay? So the main idea is slightly different from ANOVA, right? It's very related to ANOVA. You can also do ANOVA, right? By grouping things, right? But ANOVA don't give you the model, okay? You just do the F test, tell you they're different or not different. ANOVA don't tell you more, right? Just tell you, okay, you divide the group into men and women. They're different. Doesn't tell you how to pitch your stuff, right? Or you do the idea of the education, right? You see maybe bachelor earn more than that, but that doesn't tell you that, so you started a master, the master is very costly, right? Is it worth to do it? Okay, so the question is, we want to quantify the relationship between variables. Okay, that's the idea. Okay, ANOVA doesn't quantify that. Regression quantify that. So that's why I said regression is more important than ANOVA, right? And indeed, regression, general regression can include ANOVA. So that's why ANOVA, after you say advanced class, you can fold in rubber spin, no use. Okay, everyone use regression. Okay, so here is the use case of regression. In our class, we want to focus on X and Y, just two variables. Okay, and basically, if you learn 2021, you spend your whole life, the semester, to extend from 1x to more than 1x. That's it. Okay. You have y and a bunch of x. Okay. And don't overlook that, even though it looks like very simple x thing, yeah, but there's a lot of detail there, but we can spend the whole life there. Okay. And I told you, some of my colleagues basically spend the whole life to do regression. Okay. And many economists basically earn living by doing regression. Right. So here is the following, right? The data I have is for each observation I have x and y, right? So the example I have is income and education, right? So I have education for the first guy is x, his income is y, right? Second guy up to n guy, so on and so forth. Okay. And the idea is that you can represent this data in a scatter plot, right? If you recall what scatter plot is, right? Is you have, suppose you have x, which is education, and y is the income, right? And observation 1 here, x1, x2, right? Give a point there, right? So all the observation can be represented point in this scatter plot. Okay, so the data can be represented by a scatter plot if I don't have y and x. Okay, but note that everything we teach in this class extend to in general. Okay, but the formula is very different. But Excel calculate everything for you, so no one actually care about the formulas. Okay, just care about the final result. Okay, but anyway, this is the data we have. This is our input, right? It's not just number, but oh, not x1. Oh, sorry, my typo. This is x1, y1. Okay. This is x2, y2, right? And this is x3, y3, right? So on and so forth, right? So that's all the point can be presented. The main question is we want to have a line. This line, we want to, actually what we do is what we do in kindergarten, right? We see this, we want to fit the line, just best represent the data point. That's what we do, okay? And how to do that, okay? We'll do estimation and hypothesis testing, but that's the point, okay? And the question is, the first question is, what do you mean by best line? Okay, it's not clear, okay? There are many definitions. Actually, you do machine learning and big data, they will tell you many ways to do it. Okay. And we'll do it the most simple way. We call the least square. Okay. It's the minimum vertical distance square. So we want to find a point for the line is that this distance, you square it. Okay. Squared, that means that whether above or below the same, right? The squared. Add up is minimized. Okay. So that's the question. Okay. So you probably ask, besides doing this and that, okay, and is there any actual practice, right? And historically, you can ask who invented this method. It's by a famous mathematician called Gauss. Probably some of you may know it or not know it, but anyway, Gauss, Gauss. Okay, and then why he do that? Okay, actually at that time, people look at the sky, okay, and they see the comets, right, flying around, right, because they don't have internet, right? At night, nothing to do, right? There's no lights, right? Only candle. What do you do? Look at the sky, right? And look at the sky, what you do, right? And sometimes the comet come around the corner, right? And they come every 100 years, right? So you don't often see, right? And people are curious. Okay. When they come back. So Gauss use regression to predict when you come back. That's why he become very famous. This 100 0, 700, look at when you come back, run the regression, get a good estimate. Okay, of course, I didn't tell people he's doing the regression, but that's how one of the reasons why I become very famous for predicting that. Okay? But anyway, now, so basically it's just the idea is like we have x and y, right? We try to draw a line. Okay. So what is the crucial part in this model here, right? Although drawing a line is very simple, but in illustrate one point, we didn't explicitly learn before is we basically condense our knowledge from the data to a simplified model, right? The information from data is condensed in the knowledge of a slope and intercept, right? You just tell me this a line represented by the y-intercept slope, right? Right? Just tell me y equal to a plus bx, right? I just tell me what's a and b, and that's it, right? Basically, this is the form we're doing, right? What's the the idea, right? Is I'm looking at the a, right? I condense the line, which is a and b, right? What's a and b? A is the value that when x is equal to 0, right? It's the intercept, right? So basically, we call the graph here x and y. This is a, right? The y-intercept. The height is called a, right? And b will be the slope. I hope you still remember slope, right? Slope is how steep it is, right? Is the rise over run. So a line, straight line, right, can be already represented by the y-intercept and the slope, right? So basically what we're doing is we condense all our knowledge from the data into a line, into two numbers, right? So that is a crucial part of statistics. Usually what you do is you condense what you know in real very complicated object into under some mathematical object, a line, and you give number. That's it, right? So what you learn the whole complicated world can be simplified by something very simple. So that's the magic of statistics, right? Of course, we have to next class talk about how to estimate this, right? We want to do hypothesizing on that and how to use this model, right? But this is the goal, right? Because we know how x and y are related. Don't worry, we just tell you how to do Excel. Not going to teach you too much about that, but the idea, right? How to estimate it. Okay, and let's see some graph before we go, because I guess that would be important. So, a little bit math. Okay? Don't worry, just to say what I have said. Okay. So the data x1, y1 up to xn, yn. The line is called y hat. Okay, maybe I just write down here is easy. So this is y hat, right? A plus bx, right? And this is a here, right? So this point is x3, y3, right? And this point is y3 hat, a plus bx3, right? And we call the distance is y, we call d, the height is called d3, right? d3 just y hat 3 minus y3, right? So we add every d together, right? This is d3, this is d2, and this is d1, right? We try to minimize, we find a and b to minimize d1 square plus d2 square plus d3 square, right? So we just try to move the knob and down, right? Change the a, or we rotate the thing by changing the b, such that this distance, some of them is minimized. Okay, and don't need to worry about the calculation. Okay, because everything will be Excel. Okay, and because the derivation requires calculus, I'm not going to tell you the calculus. Okay, but the thing is, you try to minimize the vertical distance. Okay, square of that. Okay. So that's right. Minimize the vertical square. Okay. And This is the final slide I talked about. Don't worry, you never remember this. Okay? If I'm not teaching this class, I'm not going to remember it. Okay? The only thing I want to say is the following. One is from this definition, this means that it passes through the center of the data. What does that mean? X bar, Y bar is the center of data. The best line would be passing through the point where you look at the X, right? You calculate average of X, give X bar, right? And look at average of Y, give you Y bar. And what it means that X bar, Y bar is the center of data, and the line always pass through the center of data. That's the first result. Okay, we don't prove anything, just let you know. The fact, if I have best fit line, it will pass through the center of data. That's it. Okay. Property, right? Of course, you don't have to remember, but just an interesting fact. Okay, a fun fact. It's a trivia. Okay, something you would want to tell people. Okay, the next one, very simple. Last thing I want to talk about today, this guy. What should be the slope? Okay, the slope is a fraction. The numerator should be something you become covariance, right? So they're related. The larger the variance, covariance they must be larger, right? If covariance positive, be positive, right? Covariance negative, the slope was negative. So that's fine, right? There's nothing new there. The only thing there is variance of B divided by that, okay? And that's very simple because B multiplied by X, right? The larger the scale of the X, right? The smaller the B should be, right? Because you run the regression, you multiply B by 1,000, you should have the same line, right? You just magnify the scale, right? So that's why, that's it. Okay. Basically, we call a rescaled covariance. That's what I said. Okay. So that's it for today, and you should be able to do your revision because no regression is not in the exam. Okay. So I see you next week. I stay around to answer any questions.